So, I bet you guys will think these are pretty simple. We're solving for x, right? Directions say solve. First problem, if you want x by itself, it's locked inside a radical right now. How do you think you might release it upon the world? How do you get inside there? How do you get rid of square root? You square it. But if it's an equation, then you finally, if it's an equation not simplifying, like the last section we've been working on, we'll come back to that with cube roots. You can't just like square both sides because there weren't both sides, but now you've got both sides. So if you square one side, you can square the other side, and things will come out nicely. So when we square the 20, what do you think? Is it going to be, even though it's not a square number that we know, it's a rather large number, think about it for a second. It's going to be like 2 squared, which is 4, so is it going to be like 40, 400, 4,000? I think if you think about it for a second, you'll settle down to that 20 squared is 400. And they cancel out here, of course. All right, so then we've just got to divide by 2. 400 divided by 2 is 200. Okay, so second one. What about this one then?
Just square on both sides.
Yeah, I mean, like the square root's already by itself, right? We're going to run into a couple problems that are a little bit more complicated. They'll have squared not by itself yet, but if it's by itself, get rid of it right away. Square one side, square the other side. It cancels on the left, so we get x minus 8. 3 squared we get on the right is, of course, 9. And if I want x by itself, I'm going to just go then plus 8, right? So plus 8 on both sides. What's 9 plus 8? 17. Done. You can, of course, check any of these to make sure they're working. On the simple ones, I don't think there's any need to check them. So, okay, so then how about this one?
You like terms first.
If you square it first, which, by the way, you can do, then when you square the left side, there's going to be a plus in the middle. And this is going to be like one of those problems we just went over at the class today when we were grading. So won't it like blow up? Because you're going to have to like distribute all kinds of stuff by all kinds of stuff. You can do it that way. It just makes it a lot harder. A better idea is to subtract a 4, yeah. So if a radical is not by itself yet, good idea is to like make it by itself so you don't have that problem. So then we're going to have this. Well, that equals 3, and now you can square it, because now you don't have to worry about FOILing anything out, expanding anything out. Just cancels. And then, of course, I'm going to want to add 1, and then, of course, I'm going to want to divide by 2 to get my answer. So far, we've also been only getting one answer. I think it's possible to get more than one answer with this. And by the end of the week, we're going to start looking at the graphs of these dudes, and you'll really see why it's possible to get more than one answer, I think, then. But let's see if we get more than one answer on one of these. Let's see. So this guy, you've got 2 square roots this time. You've got one with a variable, one without. Here's x, right? Any ideas what we should do first? You can square right now, but like I said, it's going to explode because you got to write the things twice.
Oh, add 1.
Add one of them, or subtract one of them. Get 1 on one side, 1 on the other side. I'd add this one because it's really just a number, isn't it? It's just a number. I don't see any variables in there. So I'm going to do that on both sides. Going to take notes, Mr. Gibson? Might want to, you know. Now it looks just like several of the other ones. Now I think we can square. We'll be able to cancel both of these out and have no roots left, which would be nice. We'll have, what? 5x minus 4. What's this thing? When you square it, 36? It's just 6, right? Square root 6. Square root 6 is 6. Add your 4. Divide by 5. Still just one answer, looking like. Sweet. Let's try this guy. You guys want to move something first? Or you want to square it right away? Yeah, because we can just get rid of this right away, right? Like there's not two things over there, you can square it. Alright. So we've got 6 minus x equals x squared. Not a line anymore.
No.
Now what kind of equation do we have? All these other ones left us with a line, which was nice. This one leaves us with what kind of equation? Parabola one. Parabolic equation. Great. Parabolic equations, there's a couple options you guys learned this year. I think you learned 2. You can solve them by...
Substitution of
That's systems. Good try. Good try. Do it. I don't think distributing had anything to do with it. You got to find the zeros. Zeros are the solutions. Vertex is not.
Okay.
We learned how to factor to find zeros, and we learned how to use this big thing, the quadratic formula. And we did use our calculator sometimes too, you're right. So no matter what, you always set it to 0 first. So I'm going to set it to 0 on that side, so I keep x squared positive. So I'm going to go minus 6 plus x, so that I can try to factor this maybe. Ran into the hole on my board. Okay, so that's a parabola. You can either factor it or try to use the quadratic formula. Your choice. Sometimes factoring doesn't work. I think it works this time. You guys tell me, how's this factor? I'm going to put lots of factoring on your finals, so we cannot forget that. We use what they share, difference of squares, or last number.
I know it's no equation.
Oh, we got to practice this tons, you guys. Come on. Like, did we waste our time doing all that practice?
It's x, and then I think we're doing what they share. But it's, or, sorry.
I hear these guys. They're telling me what to do. Sweet. So, is it difference of squares, though?
Yes.
Is this square? Is this square? Is there 2 terms? Is there minus? No, so there's not a difference of squares. Do they share anything? All 3 of them? Do they share anything?
No.
No. So it's got to be the last number, and that's what these guys are telling me. Factors is 6. We got like
2 and 3.
2 and 3, or 6 and 1.
2 and 3.
2 and 3 is the way you want to go to get 1, right?
And then x. And then plus minus.
That times that's negative 6. 3 and negative 2 gives you 1 if you add them. Okay, the whole point of factoring is so now you can think about when either thing is 0, the whole thing is 0. So what can I plug here to make that part 0? If I drop 2 into this slot, then that's 0, so the whole thing is 0. So one answer is 2. If I drop negative 3 here, this thing is 0, so the whole thing is 0. So another answer is negative 3. Now some radical equations have 2 answers, so that's totally fine. Some of them don't. In fact, a lot of them don't. So you should be skeptical of these. So I'm going to check these over here. So I'm going to drop them into the original equation. Remember, without this blue stuff, this was the original right there. So I'm going to drop 2 in first. I'm going to say, all right, square root of 6 minus 2. That's the square root of 4, which is 2. Is that equal to 2? Yes, it is. That one works. Negative 3 might work, it might not. It just depends on the problem. So if I put negative 3 in, then I get 6 minus the square root, or excuse me, minus negative 3. Is that equal to negative 3? Minus a negative is plus. Square root of 9 is 3. Is 3 negative 3? This is an extraneous solution. It popped up for some reason that I'm not going to get into a lot this year. So if you get 2 answers, I'd be skeptical. They can both work. Neither one of them can work too. It just depends on what the shapes involved look like. So when we look at the graph later this week, I'll kind of show you a little bit of the graph and why that happens. Okay, let's look at like one more of those like that. Okay, what do you want to try first?
Minus 4.
Minus 4, I love it. You've got reflexes already full. That's awesome. Immediately. How do you decide to like move the 4 immediately?
Just left side.
There's no variables. It's
And
not
get it,
mixed up with
yeah.
other stuff.
Yeah, and you're trying to get the square root by itself too. Very
Yeah.
good. Okay, good. So now we're going to have this. And another reason besides that you should think about moving that 4 is because squaring the left side now totally cancels out. If you square up here, you have to write that out twice, lots of distributing, it gets very yucky. Okay? But if you square now, at least on this side, it's going to go away. So you're going to get 5x plus 4 only. On the right-hand side, am I going to get this? That is really, really bad algebra. 2 humongous mistakes. What's the first one? Or one of them?
It should be two different.
There should be 3 things. Great. So Lindsay's saying, like, there should be like 3 things. I've seen that a lot now. And like, there should be like 3 things. One of them's missing. That's one big problem. What else is a big problem?
The 16 minus 16.
Yeah.
That was the answer. You multiplied 2 negatives.
Yeah, perfect. You got it, Miss Collins. You're on it. She's saying -4 times -4, -4 squared, in other words, should be -16. It should be positive 16. So that's one thing.
And then
The other thing is there's something totally missing.
Yeah.
So really, you just can't do this. You can't go like that. You got to say, oh yeah, this thing squared really means put another one there. Or think about your shortcut formula or whatever. So you get x squared. Here's the negative times negative, which is easier to see, right?
and 8x.
So plus 16 is part of it, totally, but there's more. There's these 2 multiplied by each other,
Which isn't, yeah.
and those 2 multiplied by each other. In other words, there's 2 of those, so you get -8x. Perfect, okay. All right, now that's a parabola again, so we're gonna do what we did last time, set it to 0. So I'm gonna set it to 0 on this side. I always target making x squared positive. So I'm gonna say 0 equals x squared. If I subtract 5 from -8, it's -13x. If I have 16 and I subtract 4, that's 12. Now this could factor, this could use the quadratic formula. I picked one out of the book, so I'm hoping it factors, as your problems probably should. So it's a little easier. Algebra 2, there's definitely ones there. You've got to use the quadratic formula. Does that factor like that? I think it does. 12, you got 4 and 3, 6 and 2. It's 12 and 1. Very nice. 12 and 1. Signs?
They're both negative.
-12 times -1 is 12. -12 and -1 is -13. Sweet. So I could plug 12 in here, get an answer. And I could plug
And
1 in there to get an answer. Maybe they're both answers. Like I said, you cannot assume. Sometimes they both work. Sometimes neither one of them works. Sometimes one works. Most of the time it's just one. I wonder why that is. Something to do with the graph. So where should I be plugging these in to check? Way up here.
Yeah.
So we're going to go square root of 12 times 5 is 60, so I'm not going to show that. Plus 4 equals supposedly 12. That's the square root of 64. So that's a nice one, isn't it? Isn't that 8? 8 plus 4 is 12. Yeah, that's good. If I plug in 1, so there's 1 check. Let's see, I'll get square root of 5 times 1 plus 4, and it's supposedly 1. That's the square root of 9. Square root of 9 is 3. This says 7 equals 1. No. Not an answer. Okay? When I show you the graph, I think you'll see why usually you just get one answer on these ones. Okay? So we'll stop there for today.